and I'm going to start this off by calling to this stage several panelists. We need Tony from Rohde and Schwarz, and Brian, myDevices. Fantastic. And then we also have Jason White from NI. Are you out there? Jason? Oh, fantastic. All right. Yes, we're starting off well. Everybody's here. So the way we're going to kick this off is each of these guys is going to give you a quick introduction to who they are, what their companies do, so you can get a sense of their perspective from the ecosystem. Then we are going to jump into Q&A. I have a bunch of questions for them, but I want you guys to come up and please throw your 2 cents in. So yeah. So let's let's see. So let's see, Tony, it looks like you're up first.
Great. So my name is Tony Opferman. I work for a company called Rohde and Schwarz. They're based in Munich, Germany, which if you guys have been to Oktoberfest, we're just down the street from where all those tents are put up. So it's one of the benefits of working for a German company. We're about a $2 billion company, 9,000 employees, and we put a lot of R&D effort in. You could see there were about 17% of our sales goes back into R&D. They have many different divisions within the company. The one I'm most focused on is test and measurement. That's probably about half our business. And you could see the different markets that we go after in the test and measurement business. Wireless devices is where I primarily put most of my effort. But we also cover the network operators when it comes to field testing, as well as the test houses. And then this slide just kind of highlights the design test cycle for IoT devices. This is typical for any wireless device, whether it's a cell phone or an IoT type of device. You start off with some research and design type of testing, then you move into more of a design and validation test. And then once you get further down the road, you do pre-certification and conformance testing. So you're looking at the specifications, making sure you pass the conformance test. You're looking at the network operators, making sure you have coverage for their test plans as well. And then once you go through all that testing, you also have to do manufacturing of the product. So there's some manufacturing tests that are typically done, RF verification, RF calibration, and some functional testing at the manufacturing point. And then finally, as your devices get out in the market, they might be sent back for service, and there's some service and repair type of tests that happen. So this is just a high-level release life cycle of a device. And then we'll probably talk about this during the panel, but these are some of the testing challenges that I see for IoT manufacturers. The biggest area is the lack of wireless test experience, and then the cost of testing. Those two are probably the 2 primary challenges for IoT manufacturers. And then there's, of course, trying to determine what exactly you need to test. What type of certification do I need to go through? What type of carrier testing do I need to do if I'm going into Verizon or AT&T? And then finally, how to implement these tests in your lab. What do I need? What type of expertise do I have to have my engineers, and what sort of equipment do I need? So these are the 4 categories of the testing challenges that I see, and we'll talk further on that later.
Absolutely. Jason, I think you're up next.
All right, my name is Jason White, and I'm a Director of Marketing in our RF and Wireless Test Division. So much like Rohde and Schwarz, National Instruments is a pretty large company that focuses on test and measurement and automated control. The business that I focus on specifically is around our RF and wireless test products. So if you look at the view that we have of IoT, it's a very broad view. And National Instruments manufactures 2 different types of products. On the one hand, we're very active in creating platforms and products for doing embedded measurement and control. So in that way, you could say that National Instruments actually creates industrial IoT devices. And so many of the same challenges that our customers face who are trying to test embedded devices, we also face as we create those embedded control and monitoring devices. Specifically, some of the things that this picture makes me think about are some of the criticalities of having good test coverage from top to bottom when it comes to developing an IoT system. You've got everything from pretty simple devices out in the world where we don't necessarily think about issues like security, to highly complicated machines that may actually be controlling things where security and real-time control and latency become life or death kind of matters. And so it's critically important that when you think about how your IoT widget fits into the rest of the ecosystem, that you're starting with a tested widget, and that you also understand who the consumers are, and everything up on top of that, all the different layers of software and control. So for us, I mentioned that we make IoT devices. So that's the picture there on the left. That's a device that you might find installed in a factory or an embedded machine. It's an embedded computer with wireless and wired interfaces and a bunch of modules that you could connect up to sensors. So it's much like any other generic IoT device. The thing on the right is a flexible platform that we create called PXI. And in PXI, you can insert different modules with different types of measurements. So, for example, if I wanted to test a Nest thermostat, I've got wireless interfaces, I've got humidity sensors, temperature sensors, motion sensors, I've got touch sensors, I've got a display. All of those things can actually be tested within a single test platform, and that's one of the things that we offer with PXI. So back to the Nest, it's like the most popular IoT example. I like to use the Nest example because it's familiar to everybody. We see it in every store. While it's a consumer device, it also has legs into many industrial applications because, frankly, it's quite similar to something that you would find anywhere, in a factory, anywhere. And if you think about that device, it's amazingly simple. It sits on your wall, it shows the temperature, it just works. We're all happy with the way it functions. But when you think about all the different things that are inside that device, you've got wireless radios, you've got different types of radios, not just one, but multiple types of radios. It's an embedded computer that's running embedded software that gets firmware updates on a monthly basis. You've got sensors, you've got batteries, a lot of different things to test. And then you think about all the places they have to test, and just like we just talked about, it's going to get tested by the guys that make all those chips along the way, and they produce them, I consume them. Now I'm building my widget. I test it in R&D. I test it when I verify my system. I test it when I look at the different layers of software. In some different areas, I might have some conformance type tests that has to be done. And then finally, I have to produce that device in mass production. And there's stages of test there. And one of the best things about this example is you think about what a Nest costs. It's a $250 device, which by consumer standards is actually a pretty expensive device. And so I don't know about you, but as we progress forward, I wouldn't expect the Nest to get more expensive. It has to get cheaper and cheaper and cheaper to see widespread adoption, as many IoT devices do. And that starts to force a lot of change in the way that we drive down cost of test and we integrate more things into our test systems.
Okay.
Thanks.
Great. So Brian?
Great. Can you hear me all right? Okay, good. So I'm kind of the black sheep on this panel. I'm actually coming at this particular topic from a very different angle, from the cloud software side. But it'll make sense in a second when you see what my company does. So I'm Brian Bielawski. I'm the business development manager for the Americas for a company called myDevices. The whole thrust of our company is to accelerate people's time to market in building new IoT solutions. So we released a product called Cayenne, which was the world's first drag and drop IoT project builder. We took all of the coding out of IoT and put it into a very simple user interface so people could quickly prototype and build and test new devices. That's on the right there is what the web interface and the phone interface looks like for Cayenne. I like to describe it, it's like an easy-to-use website builder, but for IoT solutions. We're completely device agnostic and connectivity agnostic, and then we built out this big, suite of features that would allow people to prototype solutions for a wide range of use cases. And if we don't have a feature, we're pretty quick to add it when we have a customer request for it. It's actually a free tool. Cayenne is a free tool if you want to think about it as like the Adobe Photoshop of IoT. I think we have, we just hit 200,000 users worldwide using the platform, so it's gotten pretty good adoption since we launched it in January of 2016. And one of the reasons it's got such wide adoption is because we have this huge library of devices that we've pre-integrated. And we also have a program whereby a manufacturer can add their device to our platform in under half an hour. So our library of devices grows larger every day, and it makes it a very versatile platform. And then at the end of the day, as we all are interested in not just prototypes and proof of concepts, but we actually want to deploy some finished IoT solutions in the market. We all want to be the next Nest thermostat. So that's really what the platform, the horizontal tool, is there for. On top of that, we can build vertical solutions. That's where we make our revenue. And that's using an API that we developed. So we have this program on the right-hand side, or on the left-hand side there, called our IoT Ready program, bring new devices in the platform, use Cayenne to prototype, and then using our APIs, we can either build a customized application, or someone could use our APIs to build themselves a customized application on top of the platform. Great.
Okay.
Thanks, Kelly.
Great. Well, I'm going to start out with a question for you guys. And I'm really hoping that you can kind of give me some anecdotes in terms of what you're seeing people develop, where you're seeing them run into problems. So what would you say are some of the common mistakes or common pain points that people run into? Tony, I'm going to start with you because you mentioned cost, you mentioned, and I'm going to totally blank on
RF
you.
experience.
RF experience. That's really where it hits the road. So what are you seeing in terms of how are people running into problems?
Yeah, some of the problems I see are related to the fact that a lot of these IoT manufacturers don't have a lot of RF background. So they think they could just take a module, build some casing around it, put a couple antennas in there, and they're off and running. But there's many issues that you'll run into, especially with all these different technologies that you're trying to integrate into this device. A lot of those technologies use this unlicensed spectrum in the 2.4 gigahertz. So you have to be aware of the coexistence issues when you have, say, a Zigbee signal being broadcast together with Bluetooth and wireless LAN, and even some of the LTE spectrum. There's a lot of overlap between those different channels. So there's coexistence issues that people face that without an RF background you might not be aware of. There's issues with how you place the antenna on your device, how far the separation is, making sure that they're not interfering. There's a lot of RF design that goes in these products that people just don't really pay attention to. Another area I see people making mistakes is, they see modules out there from, say, Gemalto, Telit, RCR Wireless, and then they have the chipset guys like Qualcomm, Intel, Broadcom, and some IoT manufacturers will choose to go down the module route. They'll find a module vendor that they want to work with, like Gemalto, and then they'll integrate their device around that. And I've also seen people saying, I'm just going to work with Qualcomm. We're going to have the most flexible interface and design in our product, and that's going to be a unique selling point for us. We're going to have so much flexibility to change whatever we want because we're using the chip on board approach. And the problem between those two is there's a lot of differences. There's a lot of problems using a chip on board. And I'll just give one example. With the chip on board approach, oftentimes that chipset has not been certified by, say, a network operator like Verizon. If you use a Gemalto device that's already been certified, then you get to bypass hundreds of thousands of dollars worth of testing by choosing that module which has already been certified by Verizon. So that's one of the mistakes I've seen is people going down the path of the chip on board approach and not being aware of all the testing that's required if you go down that road. Versus choosing a module, your life is a lot easier, time to market is quicker, the cost of testing is a lot less expensive. So I'll just, those are the 2 points I wanted to bring up, the lack of RF experience and not knowing some of the issues with coexistent testing, where you place your antennas, and even the enclosure you put the product in, whether it's a certain type of metal or some plastic, that all changes the RF characteristics. And the other issue I've seen is people choosing a chip on board versus the module-based approach. Those are probably the two biggest areas or gotchas that I've seen IoT manufacturers make.
Jason, do you want to weigh in?
Sure, I will. So first of all, I completely agree with everything Tony said. Those are all challenges that we see on a day-to-day basis amongst many of the customers that we work with. I wanted to point out a couple more things I had jotted down. I had actually everything that he had said right here in my notebook. So a couple of things I've noticed with smaller companies that maybe have a great idea, not only might they lack RF design expertise, but just full-on system expertise. It's not so hard for me to take an off-the-shelf module, throw together a processor, get something going, write a little bit of software, and what do you know? I have an IoT widget, but that's not a product. I haven't tested it for security. I haven't tested it for environmental problems. Many of these IoT things, they're battery powered, and batteries create a whole new challenge with respect to testing, and even how to ship a product that has a battery actually is a challenge that a lot of times people underestimate. When you get to larger companies that fundamentally understand all of those design problems, I think everybody, like every company on the face of the planet, underestimates test. It's the last thing that gets to. It's the thing that the product's almost done. Hey, we gotta ship this thing right now, and so all of that testing is quite frequently shortcutted, and so it becomes a big fire at the end. Testing, if you wait till the end, can be expensive because you haven't thought through how to make your product testable from the get-go, you can also, Mr. Lodeman talked about it earlier, if I have an IoT device that actually needs to integrate with real-world signals, vision signals and temperature signals, how do I test that thing? Do I emulate that behavior? Do I actually put it in a temp chamber or put it in an environment where it has to see it? Well, those have big implications on my cost to test, which ultimately, if I'm trying to drive down the cost of IoT devices, that cost of test becomes a big issue.
Brian, thoughts?
Yeah, I'll throw just building on what Tony and Jason have said, just to throw another layer on there. I think something that I've seen a lot of, as everyone's out to kind of win the IoT race, is premature deployments of devices that haven't been fully tested, and we work with a lot of enterprise clients. And in a lot of cases, they look to us to make hardware recommendations, and I've introduced quite a few smaller hardware companies to these enterprises, and then they start using their devices, and they start putting them in just real-world situations and kind of pushing the limits, and a lot of them break or they don't perform well. And it's just hard to recover once that device, once you've now got that reputation for, I put my device into the market too early. I might have beaten my competition there, but now I've completely lost a shot at some large enterprises, which will probably never turn back to me, even if I do fix all the problems that exist with my device now. So, not shortcutting the testing and getting that device out. There's, I think, a sweet spot of time where you don't put it out too early before it's ready to actually be used by an enterprise.
Okay, great. Questions? Questions, anybody? Yeah.
So I'm going to put you guys on the spot just because we're in the test and measurement industry. I actually work with CTIA and Wi-Fi Alliance on the performance testing of wireless devices. So I work directly with the carriers, the manufacturers, and what's happening is that for years we've been testing these things, testing cell phones. The IoT devices are coming, and we've been working on some test plan related things, but the carriers have a very vested interest in ensuring that their devices perform and that nothing interferes with their network, right? So what the labs are seeing is they see these devices coming in where somebody who had a wired device yesterday decided to stick a radio in it, and they put it inside a shield. So how do we get this industry that we don't want to spend any money, we don't know anything about RF, and yet these things have to perform, right? So how do we reconcile all of that and move forward?
Who wants to jump on that one?
I'll take it, I guess, take a stab at it. It's kind of funny when you talk about driving change in an industry from a test perspective, but at the end of the day, money's what talks, right? And so if I'm a carrier and I have devices on my network that are maybe low-cost devices that have the potential to take down all of these guys, that's too risky. And I think what you're going to see over time is more and more people like the CTIA are going to have to put more regulation around how that conformance works. Even today, I see at some of the carriers, they're starting to build their own conformance solutions just because you can't trust everybody to do their own conformance. If I call Apple or Samsung or whoever, certainly all their devices are going to work. But if it's a random guy out in the middle of nowhere, he can't afford even to have a full-on multi-million-dollar conformance solution. So he's having to rent lab space or whatever else. And I think the carriers are going to end up enforcing a lot of that stuff in the markets where there is a carrier. Now you get outside of cellular where it's free for all. Your Wi-Fi application spaces and some of these other areas. I don't have a good answer to your question. I think it's a real challenge that we have to think about.
Let me just add what Jason had to say. I think it needs to come from two areas. One, in the standards. There needs to be a more formal standard body around IoT. And I think somebody brought up earlier today that there's really not a clear standards committee out there driving these types of products. So, I mean, that's a longer term goal to get some standards involved and make sure we have a common test strategy around these devices. But that's one area it needs to be pushed from. The other is from the carriers. I know Verizon, AT&T, they have their own set of tests that they develop outside of the standards because the standards is just a starting point for testing, and you have to come up with some test requirements that are specific to your network. So if Verizon and AT&T and Comcast all push back on these IoT manufacturers and say, before you get into my network, you have to pass these tests, things will change. But I think it has to come from the standards bodies and then from the carriers, the major carriers.
Jason, thoughts? Yeah, okay. I have one, and that is there's probably going to be some very expensive failures. And we'll have things like the botnets, the IoT cameras that are being hijacked, and it's one manufacturer from one country, and they're able to say, okay, unless you get your act together, see ya. And nobody wants to be the next battery catches fire. So, all right. Tony, one thing you mentioned I'd like to go into a little bit more detail, and that's thinking about modules versus starting from the ground up with a chipset design. And Jason, I'm wondering if you might have some thoughts on that.
Sure.
As people consider that decision, that's one of many decisions.
Yeah, absolutely. So, Tony summed up a lot of the issues earlier. If I go buy a module off the shelf, I've bought a product that's integrated. The RF design isn't completely done because I still got to deal with antennas, but a lot of it's done. It comes tested. Not only is it tested, but it's licensed, it's certified. So for somebody who doesn't have a lot of RF design expertise, it's a pretty safe choice. But the challenge is it's more expensive. If I'm going to buy a module, I'm going to pay significantly more than buying those chips off the shelf. And so a lot of this really boils down to an economics question. If I'm only selling hundreds or even thousands of something, I would buy a module every single time because it's the safe choice. If I'm selling millions or even billions of devices, well, then you got to ask questions about whether or not the chipset is a better way to go. Outside of that, I do have a couple of customers who they go the chipset route, even though they may not necessarily have the volumes, but they'll go the chipset route actually to give themselves more design control. If I buy a module, I'm buying a module and I get with it all the good and the bad of the module. If that's a very power-hungry module or it has higher speed data communication that I need, well, I'm paying for that capability and I'm paying for that power. Whereas if I use chipsets, I can actually optimize my design around my exact application requirements. And certainly it's not always just RF performance that I need. Sometimes it is power or speed.
Jason, I have a question for you. And part of this stems from the fact that if you look at things like Kickstarter, tons and tons of ideas for really cool IoT projects. You've also got things like Raspberry Pi. Developers and designers can kind of play around with kind of cool stuff. And Jason, I know you guys have a pretty interesting community with myDevices, and I'm wondering, if you can talk a little bit about the role that you think, developer communities, hobbyist communities, and just sort of people interested in IoT might end up ultimately playing either in, device design, device testing, crowdsource, We're seeing some of this stuff with apps, I think, particularly on smartphone for things like beta testing and whatnot. What do you think about that in the framework of IoT?
Yeah. We spend a lot of time on our community engagement. We have a very active community of kind of makers and developers who are using our platform to build new products, new solutions, using Raspberry Pis and Arduinos and such. And we're actually leveraging that community to help solve some of the enterprise needs that we're seeing. Because these are very capable developers, and maybe some of them are hobbyists. I think a lot of them are kind of on the startup level. And so now we have this kind of central database of kind of top performing IoT developers who don't yet have their solution in mind or their outlet in mind. And so we've gotten requests from enterprises, and we've looked at the market and we said there's no real solution that exists yet to solve that. And then we've set our community loose to develop into that solution, and we've actually found some pretty incredible results. Now clearly, that's kind of the pre-testing. They've got other steps to go through, but at least for some prototypes, some proof of concepts that enterprises need, we find that this community of developers is a really great pool to draw from, and you put anything in the form of a contest, and you'll have just hundreds of people submitting great ideas.
Anybody else any thoughts on, leveraging communities? Or?
Yeah, I was just thinking when he's talking about I think Verizon put together I think it's called ThingSpace, and it reminds me of what happened when Apple came out with their software development kit for anybody to go build apps. It's related to that, but on the hardware side. So, they have this community of people out there building these IoT devices, and Verizon gives them full support for software that would go on these devices to help access their network and make sure everything, attaches properly. So Verizon built their little ecosystem for these developers, kind of on the hardware side, to go off and build these IoT devices, much like Apple's success with their apps. So I think it's very important for this industry to have those sort of ecosystems set up. And I think AT&T did the same thing. I'm not just picking on Verizon, but yeah.
Okay. Any other audience questions? Okay. So I have one more question for you guys, and that is, all right, so we've kind of touched on this, that there's no single place to go for, I have this IoT idea, this is where I go to figure out how to design and test it. You've got, oh God, probably 8 to 10 different standards, radio choices you could make, licensed, unlicensed. Do you go with a carrier? Do you go with, cellular? Do you go with Wi-Fi? Do you go with Bluetooth, NFC? And, then you have GCF, PTCRB. You've got all the carriers that require acceptance testing. You've got, boutique RF engineering companies that might be able to, okay, here's my idea, you guys tell me how I need to build this. And then we have some folks in the test industry, and my impression is that there's a lot of folks coming to you guys because they don't know where else to go. So where you see people finding help, and do you have any advice as to where to start or how to get progress made for, if you have in design and testing?
It's a pretty loaded question, right? So, I think
the answer is not just come to
That's right, absolutely. I think that the first thing that you pointed out is that there's so many different standards, and every day there's a new one. We just heard about LoRa. I'm sure there's somebody from Sigfox over in the expo. People are talking about narrowband IoT and LTE Cat-M, and that's just one set of standards, and they continue to evolve over time. And I think when you're in the market of designing an IoT device, the thing you have to think about is what your target application and target market is. Putting every single wireless interface on a device doesn't do you any good if people aren't going to use it. And it just adds to your cost, adds to your test, adds to your complexity. You do have to be forward thinking, so you got to put things together. But you can learn a lot by just looking at other devices on the marketplace that are in the same class as you had. You know, I think about some of the stuff that he's doing with Cayenne. I guarantee you that you get a good sense for who's doing what sorts of applications and how those things get tied together. So I guess the first piece is don't overthink it. Look at your target market and pick the right interfaces. On the other side, from a test perspective, I mean, I think you'll find NI, Rohde, Schwarz, any of our competitors are more than happy to help you understand the test challenges in each one of those spaces. We've all got white papers on the web and so forth that can provide you with assistance. We've got you know, systems engineers and consultants to help solve some of those problems. We've also got networks of partners. So I'm going to again pick on Mr. Lodeman. He was up here earlier. He's one of the partners that we work with at National Instruments. And if testing is way outside of the realm of something that you're comfortable with, we all have partner networks that are able to solve those problems for you so that you don't have to know how to test yourself. You can outsource that to other people. Okay.
Any other quick additions from you guys?
Yeah, and I would say, and this is not a shameless plug, but I would say, you know, in that case, the existing platforms that are out there are a great place to start. You know, I've seen a lot of you know, new manufacturers come in and try to invent the wheel from scratch. And there are kits, and there are, you know, software cloud platforms, and you know, just to get started, to start prototyping, utilizing those platforms can help get those early test stages out of the way for you really quickly.
And some of those are not very expensive, or even free.
Or even free.
Yeah, just to touch on what these guys said, I think it was talked about earlier, you know, if you're a first-time IoT manufacturer and you have a great idea, go out there and see what's there today. There's modules guaranteed that have already been built with the right sensors, with the right technology that you're looking for, with the right carrier. There's stuff on the shelf today. You know, go after that product, play with it a little bit, learn about the ecosystem, and then maybe enhance it with some of your own ideas. But to get into this game, you probably should find what's already existing, and guaranteed the stuff is already out there. I mean, IoT is not new. Verizon's had their devices in their network for probably 7 to 10 years. And there's product out there today you could certainly go get off the shelf and start playing with and learning. And then, as Jason had said, you know, go to test and measurement companies and learn what it takes to bring this product to market. What type of test requirements are there for various carriers, manufacturing? I mean, there's a lot of industry experts out there you could tap into, and test and measurement would be a good place to start.
All right, on that note, Steve, you are up with another panel. So
that is correct.
Thank you all.
Thank you.